Guys, Mr. Donnelly here again, your favorite and only chemistry teacher. So today we're going to talk about how to write chemical equations from words and then balance them. This is a little bit different than what we had done previously. Remember, before I was giving you chemical equations with the chemical formulas already written down, and all you guys had to do was find the coefficients. Today is going to be a little bit different. Today I'm going to show you how to do those chemical equations from words, then find the coefficients. So the best way to actually introduce this concept is to just go ahead and give examples. I have 3 examples written on the board, and those 3 examples are exactly the same as the ones you got in your worksheets. So let's take a look at how to go ahead and write and balance chemical equations from words. So on the board here, first problem, same as on your worksheet, I have written potassium chloride plus silver nitrate yields potassium nitrate plus silver chloride. First thing we got to do is write down the chemical formula for each one of the words that we have on the board. So let's start with the potassium chloride. Remember, potassium is K, chloride is Cl. So we're mixing the potassium with the chlorine. Potassium has a +1 charge. Group 1 elements all have +1 charges. Chlorine is a group 17 element. It has a -1 charge. Crossing those 2 charges, we get KCl. Cross this 1 down here, cross this 1 down here. And of course, when we write the chemical formula for KCl or any other compound that has equal charges, we can just write the K and the Cl. Next, we go over to the silver nitrate. Silver nitrate, we're adding silver nitrate to the KCl. Silver is Ag. Ag is one of those transition metals that always has the same charge. It's +1. Nitrate, polyatomic ion. You'd have to go to your polyatomic ion for this particular compound. So nitrate is NO3, 1 minus. NO3, 1 minus is your nitrate. +1 and -1, those charges cancel one another out. We can just write AgNO3. So we write AgNO3. And then we get to this word yields. Yield stands for that arrow that you see when you were balancing your chemical equation. So we throw that arrow in there. Then we're on to the product side of this chemical equation. So we have potassium nitrate. Potassium, again, is K. K was 1 plus. Okay, let me write this up here. K was 1 plus. Nitrate, as we recall from a polyatomic ion chart, is 1 minus. So nitrate is NO3, 1 minus. Again, we have 1 plus and 1 minus. They cancel one another out. So we're just going to write it as KNO3. Then we're going to add to that silver chloride. So we're adding to that silver chloride. Silver, again, is Ag with a 1 plus charge. Chloride is Cl 1 minus. Once again, we have equal charges on both the metal and the non-metal, and that's going to allow us to actually cancel those charges out. So we're just going to write AgCl for silver chloride. Now we're going to take a look to see if our chemical equation is balanced. On this side, I have 1 potassium. On this side, I have 1 potassium. On this side, I have 1 Ag for silver. On this side, I have 1 silver. On this side, I have 1 nitrate. On this side, I have 1 nitrate. And I forgot if I mentioned it if I have the same number of Cl's on both sides, but in this case I do. 1 Cl and 1 Cl. So this would be considered a balanced chemical equation that we wrote from words, using skills that we learned previously. And those skills that we learned previously involved writing those chemical formulas and then summarily balancing those chemical equations. So we have a balanced chemical equation from words in our first example. So let's move on to the next one. The next one is aluminum hydroxide plus sodium nitrate yields aluminum nitrate plus sodium hydroxide. So here we go. Aluminum hydroxide. Al3 plus for the aluminum. Recall aluminum is in group 13, so it has a 3 plus charge. Hydroxide from your polyatomic ion chart is 1 minus. Here we do have to cross the charges down. So we're going to take that 3 and we're going to drop it below the OH. Remember, we don't have to cross the 1 because just writing the symbol for that element tells us that there's 1 of that particular element. So here we have AlOH parentheses around the OH to show that I have more than one polyatomic ion, AlOH3, so aluminum hydroxide. To that, we're adding sodium nitrate. Sodium is Na. So Na, and Na is 1 plus for its charge, a group 1 element. Nitrate, again, polyatomic ion. Find it on your polyatomic ion chart. This one is 1 minus. Here we have two of the equal and opposite charges, 1 plus and 1 minus. They cancel one another out. We just write NaNO3. Get to the yields. Now we're yielding here aluminum nitrate plus sodium hydroxide. So we're going to go yields with the arrow, and we're going to write aluminum nitrate next. So aluminum nitrate is Al, and to that we're adding with its aluminum with its 3 plus charge. To that we're adding nitrate with its 1 minus charge. Again, here we're going to cross our charges, so we're going to bring that 3 down over here. Nitrate is a -1 charge. Again, we don't have to bring the 1 down because just writing the symbol for the element shows that there's one of them. So here I have Al parentheses NO3, 3, showing that I have 3 nitrates. Then I'm going to move into my sodium hydroxide. So we're adding to that sodium hydroxide, sodium with its 1 plus charge, hydroxide with its 1 minus charge. Again, here our charges are equal and opposite, so they cancel out. I'm just going to write NaOH. So NaOH. I'm going to go through to see if my chemical equations balance what we've done previously up to this point. So here I have 3 OHs, and over there I've only got, on the product side, I've only got 1. So I'm going to put a 3 in front of the NaOH there. So that's going to balance my OHs. And then I have also 3 NAs on this side, but only 1 here. So I'm going to drop a 3 in front of the Na. That's going to give me 3 NAs, but it also gives me 3 NO3s. So here we have a balanced chemical equation from words. I'm going to box that off right there. Balanced chemical equation from words. And we have one more example to do before you get on your own and knock these problems out on your own here. So here we go. So iron metal, we have Fe, iron, good old Fe, right there. Then we're adding to it copper 2 sulfate. So we're adding copper 2 sulfate to this one. Copper, remember, is a transition metal. That Roman numeral 2 represents the copper's charge. So I have Cu, 2 plus, Roman numeral 2, and I have sulfate. Sulfate is a good old-fashioned polyatomic ion with a 2 minus charge. So it's SO4, 2 minus from your polyatomic ion chart. Those 2 charges are equal and opposite, so they'll cancel one another out. So here I can write Fe plus, canceled out charges, CuSO4, copper 2 sulfate. That's going to yield, so we're going to throw that arrow sign in there, that arrow for the yield. So we're going to put a yield sign in right there. Hopefully you can still see that on your computer monitors. Then we're getting over to iron 2 sulfate. So once again, that iron and that Roman numeral, which I should say once again that same Roman numeral. Roman numeral 2 stands for 2 plus for the iron. Sulfate, polyatomic ion chart, find it, 2 minus charge. Once again, our charges are equal and opposite from one another, so they cancel one another out, and we can just write the chemical formula as is. So I'm going to write FeSO4, or iron 2 sulfate, and lastly, I have a copper metal. So copper metal is plus Cu. Now I'm going to go back through and check to see if all my elements / compounds are balanced here. I have 1 Fe, 1 Fe. I have 1 Cu, 1 Cu. I have 1 SO4 and 1 SO4. So I have a balanced chemical formula from the words. I'm going to box it off just to show that I got the right answer there. And that is how you write chemical equations from words. Balanced write chemical equations from words. So Mr. Donnelly signing off. Hope you understood what was going on. Good luck with the rest of your assignment today, and I'll see you next time.